When we talk about climate change, we often talk about carbon dioxide emissions, and for good reason. Looking at the sheer volume of greenhouse gases we release, CO2 dwarfs others, like methane and nitrous oxide. But this doesn't tell the whole story. When we look at the actual impact of different greenhouse gases in terms of how much warming they cause, the picture changes dramatically. Methane traps up to 80 times more heat than CO2, and as a result, it is responsible for around 30% of the global warming we're experiencing today. That's nearly 0.5 degrees Celsius. Because methane breaks down relatively quickly in the atmosphere, this leads to a crucial opportunity. Imagine we would stop all human-caused methane emissions today. The excess methane would be gone within 12 years. This means that we would ameliorate nearly a third of global warming in the short term. That is significant. CO2, on the other hand, is a lot more persistent. Where does methane come from? About 40% comes from natural sources, like wetlands and thawing permafrost. The rest is from human activities, like fossil fuels, farming, and waste. Methane forms in oxygen-free environments, where anaerobic bacteria break down organic matter. This happens in submerged soil, like in wetlands or flooded rice paddies, and also in the stomachs of cattle, or even in your own stomach. Let's take a closer look at the world's largest methane emitter, the People's Republic of China, where livestock farming, rice cultivation, and manure account for nearly 40% of national methane emissions. Recognizing this, the PRC released its first Methane Action Plan in late 2023, which operates under the umbrella of the 14th Five-Year Plan. It specifically targets methane reduction in agriculture, alongside energy and waste sectors. The Asian Development Bank has been supporting many of the PRC's efforts to reduce methane emissions while increasing productivity and enhancing food security. For livestock, this includes strategies to improve feed efficiency, so animals produce less methane, using blends of ingredients like forages, grains, and supplements. Other efforts involve capturing methane from manure to use as biogas, or processing manure differently to reduce emissions. For rice paddies, a key technique is changing water management practices. For example, alternate wetting and drying, or mid-season drainage, involve periodically draining the fields. This interrupts the oxygen-free conditions, significantly cutting methane production without reducing yields. Better management of fertilizers and leftover straw is another way, and new rice varieties that use less water are showing promising results and are already used by some farmers. Implementing these solutions involves improving farm productivity, investing in research, and overcoming barriers through better policies, financial incentives, and farmer support. Countries like China are already taking steps in this direction with dedicated action plans. So, while CO2 remains the long-term climate challenge, slashing methane buys us precious time in the climate fight. By targeting major sources like agriculture, we can make faster progress toward climate stability.